Welcome to the first episode of our Calculus 1 series. If you have ever wondered how mathematicians solve problems involving change and motion, then you are in the right place. Today we are diving into limit laws, the building blocks of calculus. Whether you're a beginner or just brushing up, this series will guide you step by step through the fascinating world of calculus. Let's get started. Now, let's look at a theorem. If L, M, C, and K are real numbers, then we can have a limit as s approaches c of f of x equal to L, and limit as s approaches c of g of x to be equal to m. Then we have these properties. So what this is basically saying is that when we have a limit as x approaches c for the first one of f of x plus g of x, then we can distribute the limit. Then we are going to have L plus m, since limit as s approaches c of f of x is L, and limit as s approaches c of g of x is m. The second property is the same thing, just that over here instead of addition we have subtraction. So we are going to have, we distribute the limit, then we subtract m from L. For the 3, we have limit as s approaches c of k times f of x. So in this case, we have k to be a constant. Now, whenever you have this kind of limit, you always write the constant outside, then you write your limit as s approaches c of your function. So that is why we have k multiplying L. For property 4, we have the same thing, just that instead of addition or subtraction, we have multiplication. So in that case, we distribute our limit, then we multiply the two limits. For the property 5, we have division. So we use the same idea, right? We just have L over M. Property 6 is where we have the power rule. So for the power rule, we can have, over here we have limit as s approaches c of f of x to the power of n, and this is equal to, so in that case we remove the n as an exponent outside, write the limit function. Now the limit is L, so we have L to the power of n. For point 7, note that whenever, this is the root rule. So note that when you have limit as s approaches c of n, then the square, that is the root of f of x, where n can be any root number, right? Now we can always write it as limit as s approaches c of f of x. Note, whenever you have any root, it's the same thing as writing 1 over that number, right? So now in this case, we have 1 over n. We can write the limits and the function in one parenthesis, then we write the exponent outside. Note that limit as s approaches c of f of x is always L. So in that case, we have L to the exponent of 1 over n. For property 8 and 9, whenever you have limit as s approaches c of a constant, let's say we have a constant 8, we are always going to get that constant. Whenever this is always a constant, irrespective of number, as much as it is a constant, you always get a constant back. So limit as s approaches c of -2, this is the same as -2. Limit as s approaches, let's say 5 of 7, this is always equal to 7. Irrespective of the c value, if this is a constant, you always end up getting a constant. Now for the property 9, whenever you have limit as s approaches c of x, this is always equal to c. Now why is it so? Note that when you have limit as x approaches 6, and this is x, you are always substituting the value that the limit is approaching, right? So in this case, all that we have to do is, since this is s, this is not a constant, we just have to replace this x by 6, right? So we have 6. Limit as x approaches 0 of x, what is this going to be? This is also 0, right? So these are the properties that we are going to use to solve limit questions that has got to do with limit laws, right? So now let's begin with our first question. Question 1. Let's find the limit as x approaches -1 of s cubed plus 4s squared minus 3 all over s squared plus 5. Now, whenever you have a limit question, the first thing to do is to try and evaluate it at that value, right? So now let's put 1 inside our expression. If we do so, we are going to have a limit as x approaches -1. We have -1 cubed plus 4 minus 1 squared minus 3 out of -1 squared plus 5. Okay, so we are going to have limit as s approaches -1. Now, -1 cubed is -1, -1 squared is +1. Then we multiply it by 4, so we have +4 minus 3. Then -1 squared is +1, then plus 5. Then we get to see that this is the same as limit as s approaches -1. Now, -1 plus 4 is +3 minus 3, that is 0. Then 1 plus 5 is 6. So this is the same as writing limit as s approaches -1. 0 over 6, remember, this is always 0. So note that the limit as s approaches any value of a constant, this is always equal to that constant, right? So this is always equal to 0. And this will be our value. Let's move on to a different question. So evaluate limit as s approaches 1 of s squared plus x minus 2 out of s squared minus x. In this case, the first thing to do, remember, always put inside the limit value, right? So now, since x is approaching 1, put inside 1. If we do that, we get to see that we have 1 squared plus 1 minus 2 out of 1 squared minus 1, which is 2 minus 2 over 1 minus 1, which is 0 over 0. Now, this is an indeterminate form, so we can't leave our answer as 0 over 0. What do we do then? Notice that we have polynomials. Now, whenever you have polynomial, you can factorize them, right? So when you factorize the numerator, what do you get? You get x minus 1, then x plus 2. Now, looking at the denominator, since x is common between both terms, you can have x here, there is an x here. So you can factorize x out, then you're going to have x minus 1. Because if you multiply this x by this x, you have x squared. This x by 1, you have minus x. I hope this is clear. Now you get to see that x minus 1 can cancel x minus 1 right here. So we are going to have limit as s approaches 1 of x plus 2 over x left. So now let's put inside 1 to see if we are going to have any problem. So now limit as x approaches 1 of 1 plus 2 over 1. This is limit as s approaches 1 of 3. Remember, limit of a constant is that constant. So your answer is 3. I hope this is clear enough. Okay, now let's move to the third type of question that you might get, right? Now you can have this. Let's say you are told to find the limit as s approaches 0 of s squared plus 100 minus 10 out of s squared. Now, the first thing to do, as always, is put in the 0. If you put in 0, you get to see that you have 0 squared plus 100, then minus 10 out of 0 squared. Now, this is 0 squared is 0. So we have root of 100. So root of 100 minus 10 out of 0 squared is 0, right? Root of 100 is 10. So we have 10 minus 10 out of 0. And this is 0 over 0. Note that we don't want this form of indeterminate, right? So what to do is, whenever you have a radical expression basically means that you have a square root. The first thing to do is to multiply by its conjugate. So we have limit as s approaches 0 of s squared plus 100. Remember, the conjugate that I am talking about is just changing this negative to positive, right? And if it is positive, we just change it to negative. Note that you don't have to change the sign in this to negative. That's one mistake that most students do. You just have to maintain this. The only sign that you have to change is what is in between those terms, right? This first term right here, and the second term. The sign in between them is what we change, not what is inside the square root. So we have to divide by the same thing, s squared plus 100 plus 10. Note that if we divide this 2, we get 1. So basically, we've not changed the question. It's the same thing, right? It's just some trick. So now let's multiply. Also, one thing to notice, whenever you have to multiply these two things, since the conjugate, since the radical is in the numerator, always multiply out the numerators. So this is what I mean. We use the FOIL method, right? So the square root, we'll multiply the square root first. So square root times square root, that vanishes. So you have s squared plus 100, right? Then afterwards, your s squared plus 100 multiplying this, then this. So afterwards, you have to multiply this, right? Then you do this. You get to see that those two terms will eventually cancel out. So there is no need to write that. Then the last term will be minus 10 multiplying 10. So minus 10 times 10 is minus 100, right? So you have this. For the denominator, just maintain it. So you have this s squared plus 100, then plus 10. Now, this is the same as limit as s approaches 0. 100 minus 100 is 0, so you just have s squared over here. In the denominator, you have s squared, then s squared plus 100 plus 10. And this is what you have. So now, clearly, s squared will cancel s squared, right? So we have limit as s approaches 0 of 1. We are going to have just 1 in the numerator. The denominator is going to be s squared plus 100 plus 10. So now if we evaluate at 0, we have 1 over 0 squared is, so you have 0 squared plus 100, then plus 10. So this is 1 out of root of 100 plus 10. Root of 100, remember, is 10. So you have 10 plus 10, right? And this is 1 out of 20. And that is your answer. So far we've gone through 3 type of questions, right? The first one, you just put in the value and you get to say you have a straight answer, so there's no need to do anything. The second one, we did that and we got to see that we have an indeterminate form. So since it was a polynomial, we just factorized. For the third one, we did the same thing. We had an indeterminate form, but note that this is not easy to factorize, right? So all that you have to do is to find the conjugate form and multiply by it. Okay, let's continue. Let's find the limit in, so the first one is limit as h approaches 0 of 5h plus 4 minus 2 out of h. So using the same idea, if we put in 0, what do we have? We are going to have root 4 minus 2 over 0, and this is 0 over 0. So remember, since we have a radical, we have to find the conjugate. So for conjugate, all that you have to do is to change the sign in between. Sorry, not here. You have to change the sign in between to positive, right? So you have plus over here. This is the same thing. Now the next step is, since the radical is in the numerator, just multiply out the numerators. So if you do that, this multiplies by this, you have your square root vanishing, then this times that, this times this, you get to see that those two terms cancel out. So you have to multiply the last two terms. So minus 2 times 2, you have negative 4. Then you leave out the denominators, right? So you have 5h plus 4 and plus 2. Now this is the same as limit as h approaches 0. Note that over here, 4 cancels out 4. So you have 5h, out of h, then square root of 5h plus 4 plus 2. So we end up getting, note that over here h will cancel h. So you have just 5 in the numerator, and in the denominator you have 5h plus 4, then plus 2. So now if we put in 0, we have limit as h approaches 0 of 5 over 5 times 0 is 0, so we have root 4 plus 2. So this is just 5 over 2 plus 2, and this is 5 over 4. So this is your answer. B, we have to find the limit as y approaches negative 3 of 5 minus y to the exponent of 4 out of 3. So with this question, remember the same thing, right? First of all, you put in your negative 3. So you have 5 minus, then minus 3, 4 out of 3. So you have limit as y approaches negative 3. Now negative and negative will tend to be positive, so that just leaves you with positive 8 out of 4 over 3. So this is the same as, note, since we have a denominator of 3 here, we want a number that if we exponent it by 3, we get 8. And that number is 2. So 2 exponent 3 times 4 out of 3. This cancels that. So you have limit as y approaches negative 3 of 2 to the power of 4. And note that 2 to the power of 4 is 16, right? Limit of a constant is that constant. So our answer in this case is 16. I hope this is clear enough. Okay, let's move on. Let's look at this. Limit as y approaches 0 of 5y cubed plus 8y squared out of 3y4 minus 16y squared. Now the first thing is, if we put in 0, clearly we can see that we are going to have an indeterminate form, which is 0 over 0, right? So in that case, what you have to do is, first of all, since this is a polynomial, you can simply factorize common terms. So with the first one, you're going to see that we can factorize y squared here and y squared here. So in that case, we have y squared outside, then 5y plus 8. In this denominator, we can also factorize y squared as a common term, right? So we have y squared, then this is 3y squared minus 16. So now, the y squared terms cancels out. So you just have limit as y approaches 0 of 5y plus 8 out of 3y squared minus 16. So now if you put in 0, you get to see that you have 5 multiplying 0 plus 8, 3 times 0 squared minus 16, and this is 8 out of negative 16. So this is equal to negative 1 out of 2. I hope this is clear enough. For the third question, for the fourth one, we have limit as t approaches negative 1 of t squared plus 3t plus 2 out of t squared minus t minus 2. Now doing the same thing, we get to see that if we put in negative 1, you have negative 1 squared plus 3 negative 1 plus 2 over negative 1 squared minus negative 1 minus 2. Negative 1 squared is 1, then minus 3 plus 2. This is 1 plus 1 minus 2. So we get to say we have 0 out of 0. So note that these two terms are polynomials, so we can just factorize. Now, let's factorize the numerator. If we have t squared plus 3t plus 2, how do we factorize? Always multiply the coefficient over here, which is 1, by the constant, which is 2, right? So we have 2 in this case. Then we find the positive and negative factors of 2, right? So you can have negative 1, negative 2, positive 1, and just 2. Then out of these 4 numbers, we want 2 numbers that if we add, we have positive 3. But if we multiply, we have positive 2, right? So we can have positive 1 and positive 2. So we can rewrite this as t squared plus t plus 2t, because we are selecting these 2 numbers, plus 2. Now, first of all, we factorize by grouping, right? So these 2 terms, what is a common element? The common element is just t. So you can have t plus 1 out in here. Then between this and this, the common element is 2. So we can have 2 outside and t plus 1. So this just simplifies to t plus 2 and t plus 1. Let's factorize the denominator as well. We have t squared minus t minus 2. So doing the same thing, this is 1, right? So you multiply by this, we have negative 2. So positive and negative, right? So which 2 numbers do we have to select? Note that we can have 1 and negative 2, because if we add them, we have negative 1, and if we multiply, we have negative 2. So this is t squared plus t minus 2t minus 2. So the first two terms, you have a common t, then t plus 1. For the next two terms, remember, the common term is minus 2, then t plus 1. So we have this and this. So that is t minus 2 and t plus 1. So meaning that our limit, our question now becomes, the numerator was t plus 2 over t plus 1. The denominator is t minus 2 over t plus 1. So we get to see that these two terms cancels out. So this simplifies to t plus 2 here and t minus 2 here. So let's put inside negative 1. We have negative 1 plus 2 over negative 1 minus 2. And this is positive 1 over negative 3, which is the same as negative 1 out of 3. I hope this is also clear enough. Let's move on to the next one. E. Now we have limit as s approaches 1. Over here, this is x minus 1. This is x plus 3 minus 2. Note that if you put in 1, you get 0 out of 0. So now remember, whenever you have a radical, you multiply by its conjugate. Now the radical is in the denominator. The difference is negative, right? We have negative in between them. So now, instead of writing negative, we have positive. We have this. And remember, when the radical was in the previous question, when the radical over here, when the radical was in the numerator, you multiplied the numerators, right? So in this case, since the radical is in the denominator, we multiply the denominators and leave out the numerators. So we have x minus 1, then x plus 3 plus 2. Now we FOIL it out, so x plus 3, so we have just x plus 3 here, this, and now this will multiply this, and this will multiply that. You get to see that those middle terms cancels out, so we just have minus 2 times 2, which is just negative 4. So we have limit as s approaches 1 of x minus 1, x plus 3, then plus 2. 3 minus 4 is just minus 1. So now these two terms cancels out. So whenever you do the conjugate form, you get to see that you have a term that will cancel out for you to be able to evaluate the limit. So we have x plus 3, then plus 2. So let's put inside 1. We have 1 plus 3 plus 2. And this is just root of 4 plus 2. So this is 2 plus 2, and this is equal to 4. And this will be your answer. I hope this is also clear. Now, for f, we have limit as s approaches 0 of 1 over x minus 1 plus 1 over x plus 1 out of x. So if we put in 0, we're going to see that we have 1 over negative 1 plus 1 over 1 out of 0. And this is just minus 1 plus 1 over 0, so 0 over 0. So now what do we do? The best thing to do in this case is to find the LCD of the numerator. Now, having x minus 1 and x plus 1, the LCD is x minus 1, then x plus 1. X minus 1 goes into this, you have x plus 1 left. So x plus 1 times 1, so you have x plus 1. X plus 1 comes over here, it cancels this out, so you just have this left. So you have x minus 1 times this 1, so you have the same x minus 1. Then everything divided by x. So we have, as s approaches 0, x now plus x, you have 2x. 1 minus 1, that goes to 0. So we have x minus 1, x plus 1. We can have this is the same thing, right? So we have limit as s approaches 0 of 2x out of x minus 1 over x plus 1. So now we can find the reciprocal by changing this to multiplication. So this is just 1 over x. Now this x will cancel this x out. So all that you have left is limit as x approaches 0 of 2, then x minus 1, x plus 1. So now let's put in the 0. If we do that, we have 2 out of 0 minus 1, 0 plus 1, which is 2 out of negative 1 multiplying this. So this is just negative 2. I hope this is clear enough, and I hope you understand everything, right? Now let's look at this question. So now suppose that limit as x approaches negative 2 of p of x is equal to 4, and limit as s approaches minus 2 of r of x is equal to 0, and the limit as s approaches minus 2 of x is equal to minus 3. We are to find a, the limit as s approaches minus 2 of p of x plus r of x plus s of x. Now let's solve this before we move on. Note from the theorem that we first stated, right? Whenever we have this, we can just distribute the limit. So we can have p of x plus limit as s approaches minus 2 of r of x plus limit as s approaches minus 2 of x of x. So what is limit as s approaches minus 2 of p of x? That is what the question gave us over here. So in that case, we have 4, then we have 0, and then we have plus, we have minus 3. So this is just positive 1. For the b, we have to find limit as s approaches minus 2 of p of x multiplying r of x multiplying s of x. So using the same idea, right, we just have to distribute the limit. So we have p of x, r of x, and limit of s of x. So this is 4.0 dot minus 3. So this simplifies to 0. So let's move on to the c. The c part is limit as s approaches minus 2 of minus 4px plus 5rx out of x of x. So note that whenever you have a fraction, you can still distribute the limit, right? So this is p of x plus 5r of x then limit as x approaches minus 2 of x. So now we can, let me write this one well. So for the numerator, remember, we can distribute the limit. So we have negative 4p of x plus 5r of x, then everything over s of x. For the first part, note that we can always write the constant outside using the property. So we have negative 4, limit as s approaches minus 2 of p of x plus 5, limit as s approaches negative 2 of r of x, then out of limit as s approaches minus 2 of x. So using the condition, we know that limit of p of x is equal to 4, r of x is equal to 0, then s of x is equal to minus 3. So let's continue here. So that is negative 16 out of negative 3. So this is 16 out of 3. And that will be your answer. Now let's look at limits from graphs. So you can have a question like this, right? Where you are being told to find your A, B, C, and D. Now let's do it together. First of all, we have to find limit as s approaches 1. Now the 1 in question is the x component, right? So now this is 1. So when x approaches 1, basically what we are trying to do is we want to limit as s approaches 1 from the left and limit as s approaches 1 from the right. So this is 1. If we are approaching 1 from the left, we get to see that it goes up to 1, right? So we have this to be 1. Now limit as s approaches, this is 1 from the right. If we are coming in this direction, we get to see that it goes to 0, right? So this is 0. So now since 1 and 0 are not the same, we can say that the first one does not exist. So this one, the limit as s approaches 1, does not exist. For the second one, the B, now we move on to 2. So as we approach 2 from the left, from this direction, right? So as we are approaching 2 from the left, we get to see that it goes to 1. And as we approach it from the right, we got to see that that also goes to 1. So now since the left hand side limit and the right hand side limit is equal to 1, then we can see that this is 1. Now let's move to 3. So for 3, as we approach this from the left, we get to see that it goes to 0. As we approach from the right, we also get to see that it goes to 0. So since left and right are the same, we say this is 0. Now how about 2.5? Now 2.5 is somewhere in between 2 and 3, right? So somewhere here. Now as we approach from the left, we get to see that it goes here. From the right, we get to see that it goes. So it meets somewhere in between. And if you trace it, you have something like this, which is basically 0.5. I hope this makes sense. Let's solve another question to better understand the concept. Now we have this. Which of the following statements about the function y of x graphed here are true and which one are false, right? So let's take the first one. For the first one, we have limit as s approaches 0 of f of x. Does it exist? So now looking at our 0, let's look at approaching from the left and from the right, right? So from the left, we get to see that it goes towards. So if you are coming from -1, right, it goes to 0. And if you are coming from this direction, we got to see that also goes to 0. So now since both are the same, then we can say that this is true. Yes, it exists and it's equal to 0. Now B, limit as s approaches 0 of f of x is equal to 0. That's what we just established, right? From the left, we get to see 0. From the right, we get to see that it's 0. Now let's move on to C. For C, limit as s approaches 0, f of x is equal to 1. Now this is 1. If we approach 0 from the left and from the right, do we get 1? So now, if we approach 1, right, sorry, this is f of x and this is 1. So this is false, right? Because using the first one over here, limit as s approaches 0 of f of x is definitely equal to 0, not 1. So we can say that this is false. Now, for D, limit as s approaches 1. Is this equal to 1? Okay, now let's check. This is 1, right? So if we approach 1 from the right, from this direction, we get to see that it goes to 0, right? What if we approach it from the left? If we approach it from the left, clearly this does not go to 0 if we are approaching this where it approaches. So since the left hand side and the right hand side are not the same, then we can say that this is not definitely 1, because even the right hand side goes to 0. So this is false. Now let's move on to E. Limit as s approaches 1 is equal to 0. From the right hand side, we get this right is equal to 0. But note that from the left hand side, as we are approaching 1, it doesn't go to 0, right? So now, in that case, we can just say that this is also false. Now let's go to F. Limit as s approaches 1 of f of x does not exist. As we said, so from the left and from the right, we're not the same, so this is true. Now, f of 0 is equal to 0. This is f of 0, this is 0. Now, f of 0 is equal to 0? No. Now, what we use to determine this is the shaded regions. Now, looking at 0, we see that we have an unshaded region right here, right? And we have a shaded region of 0, because if you trace this, these are all zeros, right? So since we have one unshaded, one shaded at 1, then it means that f of 0 is 1. So this is true and this is false. I hope this is clear. F of 1. Is f of 1 equal to 0? Yes, it is shaded, right? And if you trace it, this is what? 0. So we can say that this is true. And is f of 1 equal to -1? No, f of 1 is not equal to -1. F of 1 over here, the shaded region corresponds to 0, not -1. So we say that this is false. I hope this explains the concept of limit laws. So this is the end of the video, and if you have any problem, just type it in the comment section and I'll do well to give you a response. Goodbye. See you in the next video.